All right, good. It looks like almost everyone's made it in through the line. Thank you very much for your interest in hearing a little bit about the EC2 container service. My name is Chris Barclay, and glad that you were able to come here to the summit today. Hope that you've had a good day. This is the last session of the day, and then there'll be a little bit more activity over in the booth areas, and we'll be there too. So please feel free to come on by and hear a little bit more about ECS. In this session, I'm going to talk a little bit about why containers have become so popular, why we built the EC2 container service, some common ways that we're seeing customers using containers on ECS, and some demonstrations that show you a little bit more about the service. So on to containers. Containers are similar to hardware virtualization, like EC2. However, instead of partitioning a machine, containers isolate the processes that are running on a single operating system. Who here in the audience has used Docker or heard of it? Yeah? OK, good. So this probably won't be too new to you, so we'll kind of blow through this. Containers are a pretty useful concept, especially if you want to be able to use the operating system kernel to create multiple isolated user space processes that can have constraints on them like CPU and memory. And the Docker CLI has been really nice in that it makes using containers much easier with commands like docker run. And Docker images similarly make it easy to define what runs inside your container and versions the entire application. And these concepts enable container automation. So you're able to define your application, build and share the application, and then deploy the image. So you might be thinking, well, this sounds pretty interesting, but why would I want to use containers? Well, there's 4 key benefits to using containers. The first one is that containers are portable. The image is consistent and it's immutable. So no matter where you run it or when you start it, it's the same. This means that this makes the development lifecycle a whole bunch easier. An image works the same on your developer's desktop and then the same in production, whether you start it today or you scale your environment tomorrow. So there's no surprises. The entire application is self-contained. The image is now the version, and which makes deployments and scaling a lot easier because the image includes your dependencies. The other thing about portability that I think is pretty cool is that Docker images are usually really small. So they're usually in the tens of megabytes for the image, and so that makes it super shareable. The second benefit is that containers are flexible. You can create clean, reproducible, and modular environments using containers. So whereas in the past, you might have had multiple processes that would be on the same operating system, for example, maybe your Ruby application server, caching, log pushing, now you can have microservices that make it easy to decouple those applications into smaller chunks. And those smaller chunks reduce complexity and let your teams move faster than they could have before, while still running the processes on the same host. So a good example of this is that you have reduced library conflicts. So if you have 2 processes that both use the same library, but maybe one ends up needing to use a different version of that library, now if they're running in 2 different containers on the same host, that's isolated, and you don't have to worry about that. This streamlines both code deployment and infrastructure management. The third benefit is that Docker's containers are fast. And by simply stating that Docker images start fast would probably sell the technology a little bit short, because speed's apparent in both the performance characteristics of starting an image as well as the application lifecycle and deployment benefits. So yes, containers start quickly because the operating system's already running, but every container can be a single-threaded development stream, so you have less interdependencies. And you also have operational benefits. For example, you can have IT manage your base image and all the updates there, and then your developers just do new Docker builds, and they can focus on their application without having to worry about all those dependencies, making it a lot faster for development and release. The fourth benefit is efficiency. Containers are efficient because you can allocate exactly the resources you want, the specific CPU, specific RAM, the disks, the network. And since it shares the same operating system kernel and libraries, containers use less resources than if you were running the same processes on different virtual machines. So it's just a different way of getting isolation. So how would you actually use containers in a deployment pipeline? Well, I mean, the first way where you'd probably start off is your ops team would create certified base images. And those base images would start from operating systems, and the operating system distros are available in places like Docker Hub. And then they would augment those base images with all the necessary patches and utilities that they might have. So maybe it's security agents and things like that that they require you to run on your applications. Those base images can then be used to create utility containers. For example, like a logging container, a Ruby container, MySQL, et cetera. And then your developers use those containers on their laptops to build in their source code. They do this by creating a container image using a manifest file, which is called a Docker file, that can be versioned and shared. And then you can customize that image at runtime using environment variables. For example, you can use the same image in a development or a test environment and customize the database endpoint that it points at. So let's kind of show this in action. Let me show you a quick demonstration for folks that may not have used Docker yet. So let me go ahead and I'll bring up my CLI. I'll find my mouse here. Oops, lost my terminal. Move that back over. Oops, that's not going to help. We all know we have to log in with the right username. All right, so let me go ahead and biggerize my window a little bit here. Oops. And hopefully you guys can see this with the font size. So basically what I'm going to do is I'm going to git clone a repository I have. So we have a sample application that's running here that we're going to run. And it's available on AWS Labs. And it's basically a simple PHP application. And inside here, I have my source, which is basically a pretty simple web page that displays a welcome message. And I have a Docker file that's in here that I'm going to use to build it. So for folks that haven't actually seen what a Docker file does, as I mentioned, basically the process here is it's my manifest for what I want built into my image. And so I'm going to start from an Ubuntu 12.04 base image. And then I'm going to perform a number of different actions to get the image to my desired state. So I'm going to go ahead and do things like installing Apache and PHP. I'm going to go ahead and add my source directory here. So this is where the source code is. I'm going to go ahead and run a couple operations. And then I'm going to go ahead and expose port 80 to the world so that people can actually see what I'm doing. So let's go ahead and git clone my repository. It would help actually if I grab my Control-C there. So let's go ahead and, oops. So we can kind of see that my repo's down here. And so the first step that I want to do is I'm going to go ahead and build from my Docker file. Thank you. Oops, and we do need a dot. OK, so I'm building my image from my Docker file. And so it's going through all the steps that I just showed you in that Docker file to create the image. And you see the nice little CLI that Docker's provided that makes it pretty simple for us to build an image. And then I'm going to go ahead and run that image. So it's going through each of the steps here. And every single step creates a new image. So basically, you have a set of images which are then independently aggregated for when you run your final container. So one of the pieces that I had put up there when I asked it to build was I created the image and a repository name, and then I put colon and I tagged it with v1. So you can actually tag and version your images in the same way as you might your source code. And then the next step is I'll go ahead and run this, this Docker image locally. So that's kind of the sort of typical pattern you might have a developer do is they're creating in their local sandbox, they're iterating on their source code, and then they're going to go ahead and create local Docker images, and they could then push their source, and there could be an automated build process that pushes that same Docker image to production or to staging environments. Okay, so now my image is built, so I'll go ahead and do a Docker run. And so it's going to go ahead and start up my Docker image. And so now I'll go ahead and just in my, my browser, grab the IP address of my instance, and let's take a look at what we've built. So voila. So that's kind of the steps you would go through in order to create your first Docker image. So pretty straightforward, pretty easy. I think it demonstrates just the simplicity of being able to create a very simple application, much as you might be doing today. And again, that's a nice repeatable process that you can fork off and have other developers on the team do. So here's the wrong place. So the Docker CLI is really great and pretty powerful if you want to run containers on your laptop. But it's challenging to scale that to thousands of containers. Now suddenly you're managing a cluster, and the cluster management can be pretty hard. So you need a way to intelligently place your containers on the hosts that have the resources that you need. And you need to know the state of everything in your system. So for example, what instances have the available resources, like the memory and ports that my container needs? How do I know if a container dies? How do I hook up to resources like Elastic Load Balancing? How do I extend whatever system I use into my deployment pipelines, third-party schedulers, or what have you? And so these are the sorts of questions we were hearing from customers that were trying to run containers on EC2, and those are the questions we wanted to answer with Amazon ECS. So we spoke with customers who are trying to run Docker containers and felt we can make it a lot easier. And that's what drove us to launch the EC2 container service. ECS has 4 key benefits for users. The first is that running modern distributed applications on a cluster really requires 2 key ingredients: reliable state management and flexible scheduling. And these are challenging problems to solve. And Amazon ECS handles the complexity of cluster and container management so you don't have to install and operate your own cluster management infrastructure. At Amazon, we've built a number of core distributed systems, primitives that can actually meet our needs for running our internal services. And we've built Amazon ECS on top of those primitives. We then expose all the state management to you behind a simple set of APIs. So you're able to get the details about all the instances in your cluster and all the containers that are running on those instances. Amazon ECS APIs respond really quickly, whether you have a cluster with just 1 instance and a few containers, or a dynamic cluster with thousands of containers. So what's a scheduler? Well, a scheduler understands the needs of your system, that is, the work that needs to be done to satisfy things like running an application or starting a container that needs 200 megabytes of RAM and port 80, and looks to efficiently satisfy those requests. It then submits the request to the scheduler, the cluster state manager, rather, and it requests that resource. And since ECS provides optimistic concurrency control, you can actually have multiple schedulers that are operating at the same time, so the cluster management will confirm that the resource is available and then commit it to that scheduler. The scheduler can listen for events from the cluster manager and take action, such as maintaining the availability of your applications. It can also interact with other resources, like Elastic Load Balancing. Amazon ECS has 2 schedulers that help you find the optimal instance placement based on resource needs and isolation policies. We have create service and run task that we'll describe in a little bit more detail. And ECS also provides the cluster state management information allowing you to integrate your own custom scheduler or third-party schedulers as well. The fourth benefit is that we designed Amazon ECS to work really well with the services you're used to and that you use. You can set up each cluster in its own virtual private cloud and use security groups to control network access to your EC2 instances. You can store persistent information using EBS, and you can route traffic to containers using ELB. CloudTrail integration captures every API access for security analysis and resource change tracking. The fourth big benefit is that Amazon ECS can be easily integrated or extended through a simple set of APIs. ECS provides complete visibility and control into your AWS resources, so you can easily integrate and use your own container scheduler or connect ECS with your existing software development process. For example, continuous integration in delivery systems. And today we actually launched a blog that describes how to use a simple CD process using Jenkins to create Docker images and deploy those images to ECS. Our container agent is also fully open source and available on GitHub, and we look forward to hearing your input and pull requests for that. During the preview, we've seen a number of patterns emerge from our early users. One pattern is using ECS for long-running applications and services. Docker is a natural for this pattern. It supports any application in any language. You define everything that's contained in the image using a Docker file, which ends up being a manifest of the image. So you don't have any more of those, oops, I made a tweak that I forgot to document situations, because everything's there documented in the manifest, which is checked into your source code repository. Your images then become a versioned artifact as well. As you saw, I can tag an image with a particular version. So the Jenkins blog shows how when Jenkins creates an image, it tags it with a unique version before it uploads it to Docker Hub. And that can be stored in a repository just like source code. And so you can then store and ship your Docker images around through your various environments or to various developers in the team. And you're testing and deploying the same artifacts. So when Jenkins or whatever build system you're using builds the Docker image, you can deploy that Docker image into your staging environment. And then when that passes all your integration tests, you can deploy that same image into production. You can also decompose your application into microservices, so you can decouple deployments even more and reduce conflicts. And then as we talked about, containers simplify deployment. Stateless servers are natural with Docker, and each deployment is a new set of containers. So as I'm scaling up my application or deploying a new version of my application, I'm just deploying those containers, and they look exactly the same whether I'm deploying them today or deploying them tomorrow. This also decreases the risk of change because rollback is simple. Because I have a versioned image that I can roll back to, updating to my images becomes pretty simple and straightforward, and we'll show you that in the next demonstration. The next pattern we've heard from users is batch jobs. Instead of a dedicated pool of resources for each job, now you can use a shared pool for multiple jobs to increase your efficiency, especially for short-lived and bursty processes. For example, Coursera is using ECS to handle automatic grading of programming assignments. Those assignments come in and are placed onto the cluster, and they run inside of a container that can then be disposed of, and the instance immediately reused by another container. So the compute resources that you're using, those are your EC2 instances, can use autoscaling, spot, dedicated and reserved instances to give you the resource mix that you prefer. So let's go through the components of the EC2 container service, and then we'll go into a demonstration of what we have. So the first thing to start off with is a container instance. These are the EC2 instances that have been checked into your cluster. You own them, you can SSH into them, you're in complete control of your EC2 instances. We use Docker as part of this, and we include an AMI that is pre-baked that you can use. There's also third-party AMIs from people like CoreOS that you can use with the EC2 container service. And it has our AMI has Docker and our agent pre-installed. And our agent processes the commands from the EC2 container service, for example, starting containers and stopping containers, and then is aware of all the resources that are being utilized. As I mentioned, it's all open source and available on GitHub, and we certainly love to see your feedback on that. The next piece of ECS is a cluster, and a cluster is a collection of resources, basically the instances and the containers that are running on it. You can have multiple availability zones in your cluster. It's just really a bucket of resources for you to use, and it's dynamically scalable. So a common pattern we see is people using autoscaling to scale your cluster up and down as your needs increase or decrease. And you can segment clusters for particular purposes. For example, you could have a development cluster and a staging cluster. You could use clusters for various teams. The third concept is task definitions. This is how you model your application. A task definition lets you define the containers that you want to run together on a particular instance. A task definition also lets you specify Docker concepts like links, so you can network between your containers that you're running on the instance. It also lets you specify things like volumes, so if your containers need to have persistent storage. Task definitions are tracked by name and revision, just like your source code. So the demonstration that I'm going to show you uses two containers. In addition to the PHP app that I demonstrated earlier, I have a time of day app that will interface with my PHP app over a shared volume. The time of day app writes the time every second, and the PHP app reads it and displays it. So here's what a task definition looks like. Let me go through it in a little bit more detail here. You can specify resources like CPU and memory, ports and volumes for each container. You can specify the command that needs to be run when the container starts. And then the essential flag specifies whether the task should fail if the container stops running. So if I have multiple containers that are running in a task and some of them need to be running, you would mark them as essential. You also specify the Docker image to use for the container. And that image can come from Docker Hub or any Docker registry, both public and private repos. So once you have a task definition defined, then the next thing to do is to schedule it. And so you want to schedule on an instance that has available resources. Once you've scheduled it, then you have a task, one or more tasks. So a task is an instantiation of a task definition. You can have a task with just one container or up to 10 that work together on a single machine. For example, you could have Nginx in front of Rails or Redis behind Rails. And so you can run tasks on your container instances, as many tasks as can fit on that container instance based on the available resources. ECS has two APIs that we give you for scheduling. Run task is a simple API that lets you randomly place tasks in a spot that fits. It's good for short-lived containers like batch jobs. Today we announced the ability to create services. The service scheduler is good for long-running applications. You reference the task definition and an account of how many tasks you want to run, and optionally an Elastic load balancer. The load balancer then routes traffic across your containers. So as you have tasks that started up, the instances are added to the load balancer. As the tasks are stopped, we remove those from the load balancer. We also use the ELB health check to know if the task is healthy or not. So if a task stops running or an ELB health check fails, then we'll go ahead and restart the task for you. So the service scheduler always tries to have the number of tasks running healthy that you've requested. You can also use this as a very simple way for doing simple service discovery. So you can use the list and describe APIs to find the services and find the ELBs associated with those services. And then you can use that as a means for one service to talk to another service. The other thing you can do with services is you can update them. For example, you could scale it up or down. I can take a service, start with 5, say I want 10, and it'll add 5 more. I can then take it down to 3, and it'll take 7 away. I can also update it to deploy new versions. So I can reference a new task definition revision, and the service will stop the tasks that were running the previous revision and start tasks running the new revision. All the while, it's still interfacing with ELB if you've asked it to use ELB, so it'll drain the connections before it stops the task. So let's go ahead and take you through a demonstration of these concepts. So typical user workflow that comes to Amazon ECS, Today, you'd probably come to the management console that we launched today, which I'll show you. You want to run the service. You're going to need to start up a pool of instances, and those, again, are the container instances on which you're going to be running your tasks. You're going to create a task definition, so that's the manifest for the containers you want to run together on a particular instance. So we're declaring our resources. I'm going to go ahead and create a service, and I'm going to reference an Elastic Load Balancer, and then tell how many of these I want to run. And then ECS will go ahead and start this up for me. So let's go ahead and take you through don't need our command line for right now. Instead, why don't we go ahead and come over to our ECS management console. So folks that have tried ECS before, you probably used the CLI. So I'm happy to announce that we've launched a management console today, which augments the CLI, certainly makes it pretty easy to come and take a look at what's running inside your cluster. I'm running out of Tokyo today because we also launched an endpoint in Tokyo. So now we have 4 regions that we support, in addition to US East 1 and US West 2, so that's Portland. We also support Dublin and now Tokyo. So this cluster is pretty boring. It has no services, no tasks, but I do have a nice pool of instances. So we can kind of see here that I have 10 instances, and we can see the EC2 instances, which ones are actually connected. Looks like I have an EC2 instance that's not connected. We'll see how that all works out with my service. And the next step I probably want to do is show you the task definitions. So ahead of time, I went ahead and created a task definition for my demonstration. I have 2 revisions here. Let's go ahead and we'll take a look at the latest revision. And we can see that I can just take a look at my task definition through the UI, both in a JSON format as well as in a clickable format. And if I wanted to create a new revision, I can just click that button, and I can make edits here in the builder or in the JSON. So one thing I might want to do is go ahead and start up a new service. So let's go ahead and create ourselves a service. And I'm going to go ahead and use the revision 2 of my demo. And let's just call this my Summit demo. And let's go ahead and start up, we'll go ahead and start up 6 tasks. And I do want to use ELB. So I'm going to go ahead and select an ELB that I created ahead of time. And I only have 1 container that I've exposed ports out of the 2 that I have in my task definition. So I'm only seeing the one with the exposed ports. I'm going to go ahead and select that. And then the last thing I have to do is get a service role. So for those of you familiar with identity and access management roles, the service needs a role that it can use in order to work on our behalf to do things like managing the Elastic Load Balancer for me. So I'm going to go ahead and select that and go ahead and create the service. And so now I've requested, we can see the desired count is 6. So I've requested that 6 start running. And I have 0 pending and 0 running. Let's go ahead and refresh and see how we're doing. So the service scheduler is going to go ahead and start those tasks. And so they go into pending, which means that we're asking the instances that have capacity if they can start running these for us. And if we were to click into any of these tasks, I can get a little more details about it. So I can see, for example, what EC2 instance it's running on. In fact, it's already running now. I can see the status of the containers. So for example, one of my containers could possibly fail. So this is a way I could take a look and see that. I can see details like the endpoint. So it gives me a bunch of information that could be useful. So now I know that I have all these tasks running, and I can now take a look at my load balancer. And let's take a look at the instances in here. And we can see that we have some instance IDs that have been added, so that's good to see. They look like they're in service, so that's always good as well. So now I can take a look at this load balancer endpoint, and let's see if my application's actually running. And so here we go. And so now you can see kind of that additional piece that I didn't have in my earlier demo because I just had my one container running. I have a time of day. And so if I were to refresh this, we can see the time is in fact moving forward as my BusyBox app continues to write the time of day into my shared volume that my PHP app is now reading from. So we have our service up and running. And if I want to scale it, let's go ahead and we'll add a little more and watch what happens. And at the same time, I'm going to go ahead and update my image. So we can see the 2 pending there. So why don't I go ahead and I'll start up a new CLI session, and we'll update my image in some way. So let me just go ahead and start up another CLI. So we'll go ahead and change into our So if we want to, we can go ahead and maybe we want to have a couple extra exclamation points after our congratulations. And we'll go ahead and do our Docker build again. Taking care, actually, to type everything right. And I'll tag this with version 2. Oops, and of course, need the dot to reference my Docker file. And it's in that directory above. So we'll go ahead and start that. And we can see that it actually goes through a couple of my steps pretty fast. So it really quickly ran through the first few steps because I've already cached those images on this machine when I previously did a Docker build. The things that it's doing differently is that it had to add the source back into var www because I updated the source. And so the steps after this are going to be run again. So now I'm building my image, and the next step I'm going to need to do once the image is built is push that up to my Docker repository. While this is happening, why don't I go ahead and check on the status of my tasks that I asked to run. So now we can see that I indeed have the 8 tasks that I requested. I'm going to go ahead and bump that back down to 6. And what I'm going to do is go to my task definition down here. And let's go ahead and create a new revision. And you guys probably know what I'm going to do here. I'm going to go ahead and, instead of just pulling from the head, I should probably be pulling from the actual revision that I want. So I'm going to update it to use revision 2. I'm going to go ahead and create that new revision. So now I have a task definition revision 3. Let's go back to our service. And take a look at the build status over here, still building. This is a good demonstration of the power of different instance sizes. T1 micros would not be the best thing to use for your build machines. So coming back over here, let's just take a look. We have our desired count at 6. Running count's now back to 6. So I successfully went ahead and decommissioned those, waiting for the connections to drain. Of course, there probably aren't that many connections to drain. But the connection draining is kind of a nice little feature there as well. So let's go ahead and we're going to do a Docker push. So with Docker, we need to push this image to Docker Hub. So I'm going to go ahead and take my demo v2 and get it off my machine and actually push it up to Docker Hub so I can use it elsewhere. So it's going to go ahead and push that, and then I can come over here and update my service. So I was using revision 2. Now I want to use revision 3. Let's just make sure that it's all up there. We'll wait for it to be done pushing. There we go. So let's go ahead and we'll update our service. So scrolling down to see the tasks. Another nice thing about the service scheduler is we have an event stream here. And so you can see what's going on with the service scheduler. So we can see, for example, that we stopped the 2 tasks when I asked it to go from 8 to 6, drain connections, and now you'll start seeing events on starting up the new task. And so let's just take a look here. We can see that we have a couple still running revision 3, some that are running revision 2. So it's in the process of updating those tasks for me. So it gives you a nice sense for how you can do deployments now using the service scheduler. So if we were to go over to, we have a couple of version 3s running. So now if you're impatient, you can start refreshing, and hopefully you'll catch one of the new ones that's running revision 3. Still a lot running with version 2, I guess. Let's see if I can catch one at least. And my load balancer. Well, there's always going direct. E43. Well, so we don't keep you guys waiting for the whole thing. We can at least go direct and take a look at one of my containers, hopefully. Almost all the way there. There we go. Thank you. All right, so thanks for the patience. The nice thing, though, too, about ECS is that if there are, it's not just about the deployments and keeping your containers running. It's also about the state of the container instances themselves, too. So if we were to shut down some of the instances that are running in that cluster, the service scheduler would see that those, not only the container instances were gone, but the containers themselves were unhealthy. It would try to find a place to start up tasks so it always has your desired count. So hopefully that gives you a good overview of the service scheduler and how that works. So autoscaling. So it sounds like we're ready to get into our Q&A, which is fine. So hopefully that gives you a good overview of Amazon ECS. Happy to take questions. So we already had a preemptive thread here that wants to hear about autoscaling. So there's 2 places you can autoscale. With ECS, you can autoscale your container instances, and that works just like autoscaling does today. So you can use metrics that you want in order to scale your cluster up and down. And then there's scaling your container instances themselves inside your service. And so we don't have auto-scaling as part of this version of the service scheduler, but you certainly could use metrics to, with CloudWatch to identify constraints inside your service, like CPU or memory utilization. And then you could just adjust the service definition to increase the count of tasks that you're running in your service. Yes, sir. Price. Amazon ECS is free. You only pay for the resources that you're using. So the EC2 instances, the load balancers, and that sort of thing. Yes? Private Docker registries. So we support private Docker registries today. There's some documentation about how you'd set it up, but it's pretty straightforward to set up, and you can pull images from private Docker registries. Yeah, it's integrated today. You can use, for example, a private repository in Docker Hub with ECS. Oh, are you asking if we have our own? Oh, sorry, yeah, we don't have our own private registry yet. Right, thank you for the feedback. Yeah, we certainly appreciate the feedback on things that we're missing. We're actively listening, so folks that are, if you want to give us feedback in the forums, we use that feedback to prioritize our roadmap. So appreciate the input on a private Docker registry. Thank you. Yep.
I have a question.
Yes.
So what about failure response rate? Say you're pushing out a build and in the first few instances you see, oh no, that's a bad build and you want to cut it. Mm-hmm. Is there a quick way to like pull the plug on pushing out a bad build?
Yeah, I mean, so you can definitely, right now the deployment happens basically in bulk. It starts to start new tasks as it's stopping tasks. If you are monitoring and you're seeing that those new tasks are looking bad, you can just go and update the service to point to your previous task definition revision, and it'll just stop the process and take care of the ones that it hasn't gotten to yet.
Thank you. I have a second question, but I'll let other people ask first.
Just a question. Are you able to resolve container linking across ECS instances?
So container linking across instances. So as I mentioned, with the service, you now have some very basic service discovery capabilities. So what that gives you is you can reference through the describe APIs the name of the service that you want to link to, and then you can get the ELB for that, and then you would point to that ELB, and the ELB is what would reference the containers that you'd need to route to or you'd want to route to. That's what's available today. If you're interested in more along that, we'd love to hear your feedback.
Question?
Yes.
So does the containers work only with the ELB, or would it also work with third-party load balancers?
So today, the service scheduler is integrated with ELB. You could definitely use other load balancing approaches if you wanted to, using things like sidecar containers. But today, the integration that we've done with the service scheduler is with ELB.
Thanks.
A quick question. Mm-hmm. So you mentioned you guys are not supporting auto-scaling right now. Does that mean you are not auto-scaling instance, or you are not support auto-scaling containers within instance?
Yes, let me clarify.
My follow-up question is, are you guys using a container cluster manager tool like Kubernetes, or you have sort of in-housing technology? How do you handle out-of-capacity problem? For example, on a certain instance, they are short of resources, so that I cannot spin off more containers, things like that. So those are all related with auto-scaling. So you are mentioning you are not supporting auto-scaling container.
Yes, let me take your first question, if you don't mind. So the first question is auto-scaling. So to clarify that, we do support auto-scaling of your container instances. Those are EC2 instances, and you can use spot, reserved instances, auto-scaling. What we don't have yet is auto-scaling the containers, but you can certainly use CloudWatch alarms to give yourself an alarm, and you can scale up and down your service. So that's kind of how you do it today. It's good to hear, though, that you might want auto-scaling containers, and so that feedback is helpful. The second question you had was, are we using something like Kubernetes? And as I mentioned, one of the key values of ECS is that you don't actually have to run any cluster management software. And in fact, we built ECS on top of some primitives that we use to run the AWS business. And so we actually provide, through very simple list and describe APIs, the full state of your cluster. And you don't have to worry about scaling that cluster management software. That's all handled for you behind the scenes. So no, we don't use Kubernetes behind the scenes. We're actually using Amazon-developed software.
Yeah, there are downside and upside. The upside is, of course, you hide those details, so people don't need to deal with those details. But the downside is that's lack of control. A lot of people want more control.
Okay. Yeah, maybe we can get additional feedback. Thanks, Deepak. Yes?
Shall I use Chef or Docker with Amazon?
Chef or Docker? Gosh. That sounds like a different session, actually. Chef versus Docker. I'm not sure I'm going to even touch that. Yeah, I mean, look, you could actually use both if you wanted to. I don't know if you've seen Packer from HashiCorp, but it supports the ability to use Chef recipes to create Docker images. So, I mean, you could use both if you wanted, I suppose.
I want to use as few as possible and get things done. So what's vision?
Yeah.
What's your vision?
Yeah, that's probably more than we can do in a Q&A, but it's a good question, and maybe afterwards we can have a talk.
I have a tricky one. So, as a medical company, we have to process patients' data with HIPAA-compliant environments. So, will Amazon cover HIPAA compliance with container services, with as we have covered, single tenancy, EBS encryption, and so on?
Sure. Yeah, I mean, so it depends kind of with all compliance stuff. There's a little bit of you know, how you're using the service. So if you're not storing any patient information in ECS, then all you're using is EC2. And, okay. But you know, we can talk more about your particular compliance needs with some of our SAs that are fully skilled up on talking about compliance questions.
Okay, thank you.
Sure.
A lot of the demos today were very good, but they were very manual. Is there a way to have more automation of the pipeline?
Yeah, so great question. As I mentioned, we have a blog on creating a CI pipeline using Jenkins, and there's actually quite a number of pipelines for build automation for Docker images that basically take a push to Git, build the image, push it to a Docker repository, and then the Docker repository can trigger a service update. And so that's actually what the blog today shows, and probably should have shown it during my demo today.
Thanks.
One click.
I'm wondering about Elastic Beanstalk. I don't really know anything about it other than it supports Docker containers. How does this compare to that?
Sure. Yeah, so Docker and Beanstalk runs on top of ECS. So Beanstalk's great if you have an application pattern that fits the Beanstalk model. So if you're focused as an app dev and you don't really want to worry about the details of how things are working underneath the covers, Beanstalk's a great model. It takes care of provisioning the load balancer for you, it sets up the auto-scaling groups, just handles all the stuff underneath the covers. If you need more control, then you could come down and use ECS. So that's kind of the quick summary.
So Beanstalk is using ECS?
Yes.
Cool, thank you.
My next question
yeah, sure.
came back around. How do you allocate resource? So if I have a bunch of large instances and a bunch of and I have a container model that say I can fit 4 containers on a box, and I deploy 10 containers, does it put 1 container on each box, or does it start filling 1 box up with 4 containers before moving to the next one?
Yep, great question. There's a lot of different scheduling algorithms out there. What we use today is pretty basic. It's a random placement algorithm. But there's a whole bunch of schedulers out there, and as Deepak mentioned, one of the nice things about ECS is you can integrate third-party schedulers. In fact, we have a blog that talks about how you can integrate with Mesos schedulers. So if you want to use a third-party scheduler or even write your own because you have a great scheduling algorithm you've been using, then you can integrate with ECS and use ECS for the cluster management and the container placement.
Thank you.
Sure.
You mentioned blue-green in your presentation,
yep.
And in the demo I didn't see that.
Sure.
So is that just a future feature? And
well, I mean, so you could do blue-green if you wanted to. So the way I would do blue-green is I would create a second service. So let's call service blue and service green, and you use the same ELB. And in service blue, you'd go from whatever you're running X to 0. And in service green, you'd go from 0 to X. And you could do that in phases. So that's a basic way you could do it yourself. It would be pretty manual today, but we could certainly imagine creating additional automation around that.
So do you guys have any specific plans to roll out something like that?
I can't comment on any plans specifically, but as I mentioned, we definitely are really eager to get feedback from customers. We've gotten a lot of great feedback during the preview, and we use that to deliver the features that you saw today. And so if blue-green is an important one, please do let us know.
Thank you.
Thank you.
So is Beanstalk one instance per container? Meaning if I ran multiple, if I scaled out my Beanstalk, I'm going to get multiple instances?
I'm sorry, if you scale down
If I use Beanstalk with a container,
yeah, so
will I have one instance per container?
So today, Beanstalk supports one container, one set of containers, so one task. So task definition, remember, is the set of containers you want to run together on an instance. Today, Beanstalk supports one task per instance.
So it's a lot more expensive then?
Well, it depends on how you're sizing. I mean, so it's tailored for running a particular workload on an instance. So you could pick an instance size that matches your workload. But again, that's the pattern that they have today. If you want a little more flexibility, then you could use ECS and you could put multiple tasks on a particular container.
Okay. And can I link EC2 Classic with this? Does it have to run in VPC?
So I'll say it's highly recommended to work in VPC.
But can I run, say, the ECS in VPC and have Classic EC2 talk to the ELBs?
Yeah, through Classic Link? Yeah. Yes, you can.
Okay.
Great. Thank you very much. Really appreciate your attendance.